Hey guys, happy beautiful Monday. I think last week we left off with talking about how whales and dolphins are really good and efficient at breathing, and they can squeeze like all the air out of their lungs and force it out with a great, tremendous force, and then inflate with a huge amount of force too, so they can be really efficient in breathing. But even better than whales and dolphins and those sorts of mammals are the birds, actually. These things are quite amazing in how they breathe. And think about it, they are using a ton of energy to flap their wings and fly. It is very expensive in terms of energy to fly. Birds have huge chest muscles enabled in order to do this, and they have a giant heart too. We'll talk about that when we get to the heart part of our notes as well, to pump all that oxygen-rich blood. But not only that, they have an amazing way of breathing that's totally different than what you and I do. So you and I squeeze and shrink a lung and then expand the lung in order to get air in and out of our bodies. Um, Birds don't. Their lung stays the same size all the time. They have are a series of air sacs, and it's going to take me a little bit of time to kind of explain this, because there's quite a few steps in order to take one breath. Birds are amazing for another thing too. They actually have two breaths inside of their body at one time, which you might think is a little bit weird too, because it's so different than you and I. But I do have this diagram because I'll kind of walk you through it, and then I'll walk you through it in a video as well, and then we'll talk a little bit about dinosaurs at the end. So if you can imagine, we are just looking at one pathway to one lung. There is the trachea. Remember, the trachea is that tube that comes down from the mouth and the nose, the nostrils, and it's carrying air, and that branches into two bronchi, right? And then here's where the air goes. So the air does not go into the lungs like it does with you and I. It actually goes to the back of the bird. On the first inhale, it goes into an air sac or a series of air sacs located in the rear of the bird. And those kind of swell up or expand in size to suck the air in. That's on an inhale. And then the bird squeezes this air sac and forces the air out of it and into the lungs on an exhale. So again, it's squeezing the air sacs to try and exhale, and the air gets forced into the lungs from the back of the bird to the front. And then the bird's going to inhale again. And this is what you have to see. That one breath of air now is going to go into a front air sac on the next inhale. But at the very same time, and this is so cool, it's inhaled, right? So there's another second breath coming into this rear air sac. But we're just following one breath right now. And then after all the air is left the lung and it's in the air sac, they exhale for a second time. And that's when the air gets squeezed out of this air sac and up out of the trachea. But remember, when that's happening, that second breath that came in is going through the lungs, and it's going through it from the back of the bird to the front of the bird. So the air is always passing through the lungs from the back of the bird to the front of the bird. There's always two breaths. Well, not always, because on the second exhale, we actually lose one breath, but there's two breaths inside of the air, or inside of the bird when it inhales. It's quite an amazing process. I do have a video too that follows one breath, and I'll walk you through it. It's linked here. You can look at it another time. I don't think there's any audio. So here's what it looks like. I'll kind of explain it. We have a bird. We have air sacs here, these little circles, and we have the lung in the middle. Posterior means rear, anterior means front, and there's our lungs. So let's follow a breath. It gulps a breath of air in on an inhale. Those air sacs inflate, and the rear one fills up, and then it exhales and pushes the air through the lungs, and then it inhales again. You can see now there's two breaths of air in that bird, and it exhales again, and the air fills the lungs again. So it's actually getting air into the lungs during the exhale, which is quite impressive. Inside of the lungs, this is where the blood at the top comes in contact with the air, just like it is for you and I. So we haven't talked about what capillaries are. They're just really tiny blood vessels. So blood that's low in oxygen comes in contact with the oxygen-rich blood. Oxygen diffuses into the blood. CO2 diffuses into the air, and that's how they breathe. And it's the same way that we do. So the lung works in a similar way. It's just how they get air into and out of their lungs. It's quite impressive. What does that mean? Well, it means that a bird like this always has air going through their lungs, fresh air. So it's always getting oxygen. It also means that because of that, they don't create what's called lactic acid. So, have you guys ever sprinted really hard? That means run really, really fast. And in track, I might have some athletes do this over and over and over again. And what happens is that you get that burning feeling in your legs. That's a buildup of lactic acid. And here's what happens. When your body doesn't give it enough oxygen, it still needs to work. I mean, think about it. If you were sprinting from a lion in Africa and you didn't get enough oxygen, you were breathing too hard, and your muscles just stopped working, you would just fall over and the lion would eat you. So we don't do that. We have another process in which our body can make energy without oxygen. The problem is it's not very good at doing it, and we don't get a lot of energy for the sugar that we use. And a byproduct of it is called lactic acid, and it's that burning feeling. It's bad in a sense in that it will eat away your cells. It's an acid. And birds will not get that burning feeling, well, as quickly because they always have oxygen in their lungs, and they actually have more oxygen in their blood. And then again, their heart's really big, so they can pump the blood really fast and with a ton of force. So birds don't get the buildup of lactic acid from a hard effort like we do. I said that building up lactic acid is bad, but as a coach, I also want to point out that it's actually a really good tool for us as coaches and athletes to make ourselves stronger and faster. So during practice, your coaches may ask you to work really hard like that. And you might feel the burn of lactic acid. And you might be saying to yourself right now, well, that's bad. It's eating away my cells. Well, it is, but if you recover, if you spend a day to recover, your cells regrow, they heal. And when they do that, they will go ahead and come back as stronger. They'll come back with more of them. You will rebuild more cells. You'll rebuild more muscle, and you'll come back stronger. And therefore, next time it's going to be harder to get to that lactic acid burning point. So there you go. A little bit about coaching, a little bit about athletics, a little bit about bird breathing, but I wanted to touch on one more thing, and that's dinosaurs, believe it or not. Some cool, interesting things coming out of science in the past decade or so. So a lot of birds, they have these air sacs tied into their bones, and you can see them here. So basically this is a turkey bone, and you can see that it's hollowed out by these air sacs that we're talking about in the bird. And we actually see the same air sacs found in dinosaurs as well. So these are all the bones affected by the air sacs, both the forward air sacs and the rear air sacs, and they are pulverized, or I guess like the holes are made in there for the air sacs. And dinosaurs have these same traits. In the bones that we found, we're able to see that they still have these holes in them, which is interesting. We can infer that dinosaurs probably had air sacs like birds. If you want to read a little bit more about it, there is this article here from Scientific America. I'll link air sacs and dinosaurs, and how actually quite a few of them had it. Some a lot more than others, but definitely quite a few of them had it. So I'll link that to the description below, but it's kind of interesting to think that dinosaurs had air sacs too. But really, they're huge, huge, huge things, and they need to get a lot of air in their bodies in order to breathe, and in order to run, in order to catch prey. And so it does make sense that possibly they breathe much like birds, in that they breathed in the air sacs, air went through lungs in a very efficient way in order to get air to that whole giant body that they had. And we've talked about it before when we get into studying all the sorts of evolutionary history of different animals. We also know that birds came from small raptor-like dinosaurs. We have all the fossils to represent that. So it could make sense that the lungs and the air sacs found in dinosaurs were ancestral to birds, which means they were there before there were birds. So pretty cool. I'll link this article if you want. It also made the dinosaurs a little bit lighter than we think, which is kind of neat as well. So fairly recent article, worth taking a look at if you want a little extra stuff, but you do not have to. Okay, guys, have a good day. Enjoy your Monday.